At the end of October 2025, the attention of astronomers across the world turned to a single, inescapable moment that would determine the entire legacy of 3I Atlas. This instant, known as the comet's perihelion, marked the passage closest to the Sun, a point in its journey about 126 million miles from our star, which scientists recognized as the most dangerous phase since the object's first detection. This intensity was not merely rhetorical. It represented the midpoint of its rapid transit, the crucial location where the immense forces of heat, gravity, and orbital motion converge in their most demanding configuration. Here, the visitor from beyond our solar system faced a definitive trial by solar radiation, its fragile ices encountering sunlight 40% stronger than the energy flux experienced at Earth's stable orbit. Nothing that had journeyed so far and arrived with such speed could possibly remain unchanged by this thermodynamic ordeal. During this severe encounter, every structural layer of 3I Atlas underwent profound stress as solar energy drove rapid sublimation, causing violent outgassing as buried volatiles escaped into the hard vacuum of space. The nucleus itself was understood not as a monolithic stone, but rather as a porous aggregate of frozen gases and fine dust, its structural stability dependent entirely on temperature gradients spanning just a few critical degrees. A single violent burst of gas could easily open an irreparable fracture, and a single significant fracture held the potential to split the body entirely, ending its coherent existence. For the scientific community, this moment represented the physical threshold where a celestial object either demonstrated its fundamental endurance or quietly ceased to exist as a unified body. This natural process, indifferent to human urgency, forced the first turn from curiosity toward deeper doubt. Instrumentation across multiple international observatories registered a significant and verifiable rise in activity just before the comet's geometry caused it to slip behind the Sun, a factual observation quickly followed by the unsettling closure of the line of sight. For several days surrounding the conjunction, every Earth-based and orbiting telescope was completely blinded by the blinding interference of solar glare. In that critical interval, the comet became physically invisible, meaning no sensor could provide confirmation of whether its surface had successfully held together or if it had fragmented irreversibly.
Before we get to that, I need your help. I'm trying to hit 50,000 subscribers by the end of the year, and I need your help. So I would really appreciate it if you could subscribe and help me out.
This consequential silence was factually necessary, yet emotionally unsettling to those watching. Astronomers understood that the moment of closest solar approach was simultaneously the most critical time for data acquisition and the one time when data was absolutely unavailable. Agencies had prepared for this predictable gap by redirecting spacecraft for indirect observation, but the orbital geometry offered minimal hope for a clean signal. As light curves flatlined into zero readings, speculation was momentarily replaced by a tense, mathematical wait. Every dedicated team knew that the object's appearance, when it finally emerged again, would definitively reveal whether it had survived its ordeal or been permanently erased. This period of forced invisibility was publicly named the acid test by experts like Harvard physicist Avi Loeb, a term that quietly encapsulated decades of astronomical discipline, placing faith in the eventual evidence of observation over the comfort of immediate assumption. The perihelion event, therefore, carried not only mechanical scientific risk, but also a profound symbolic weight. Solar proximity is a simple, quantifiable mechanical fact. Yet the consequential loss of data during that period created an intellectual void for observers on Earth. For a few days, all human knowledge about the fate of the interstellar traveler depended entirely on pure calculation alone. The sun, by its own overwhelming brightness, momentarily erased all possibility of human witness to the dramatic event it was orchestrating. Such unavoidable conditions transform human research into a kind of determined faith, a discipline tempered by the quiet acceptance of reality. This sense of confusion as honesty offered vindication to those who understood that sometimes the simple limitation of physics is confused with concealment, when in fact the cosmos itself controls the timing of revelation. Analysts reconstructed potential scenarios from decades of previous cometary encounters, estimating the precise rate at which various materials would sublimate at a distance of 1.36 astronomical units. They correctly anticipated the occurrence of strong jets and the distinct possibility of losing mass fractions large enough to fundamentally alter the object's current spin. A slight shift in rotation would inevitably redirect the outgassing, resulting in a small but measurable change in the object's overall course. For an interstellar object, even a small difference in its path after reappearance would carry meaning far out of proportion to its physical size, because slight differences redefine deep origin. The universe, in its impartiality, offers tests without sending any warnings, while institutional science naturally prefers the safety of predictability, and this difference remains central to the narrative. The moment vividly illustrated a persistent paradox within the field of astronomy. The closer humanity attempts to draw near to a profound truth, the less clearly we are actually able to see it. While 3I Atlas remained hidden behind the solar disk, the world watched an empty region of the sky, knowing with certainty that something irreversible was occurring there. The line between pure observation and the acceptance of belief grew exceedingly thin. This condition, where data must be withheld for the necessary period of verification, became the mechanism for establishing truth beyond bureaucracy and introduced the tension of scarcity, overload into the collective human experience. Institutions tracking the event maintained coordination, an effort that reflected both the complexity of the data and a determined restraint in its public presentation. NASA, the European Space Agency, ESA, and a multitude of independent observatories compared their raw data outputs, confirming the exact stated distance of the perihelion passage. For the public audience, the precision of these calculations offered a subtle relief loop and immense moral satisfaction, especially among those who had grown skeptical of earlier, over-dramatized narratives. The final confirmed distance was 1.35 AU, or 202 million kilometers, a measurement that confirmed the comet's path remained well clear of the sun's most intense magnetic influence.
Before we get to that, I need your help. I'm trying to hit 50,000 subscribers by the end of the year, and I need your help. So I would really appreciate it if you could subscribe and help me out.
Heliophysicists define the core magnetic chaos zone as lying within 10 to 20 solar radii, the region where the solar wind and magnetic fields tear at each other in continuous turbulence. By maintaining this specific distance, 3I Atlas was spared the magnetic violence, enduring only a fierce thermal assault. This distinction is physically decisive. Outside the magnetic belt, charged particles flow freely, and the comet's material behavior is governed by simple heating. Within it, plasma storms distort trajectories. The object traveled through intense heat, but crucially, it avoided the storm. This quiet correction carried deep vindication for those who doubted the initial sensationalism that had claimed the comet might be pulled in by solar magnetism. What had been presented by some as cosmic mystery dissolved into verifiable celestial geometry. The universe remained strange, but its strangeness was not rooted in deception. It was instead rooted in the complexity of distance and boundary. The official confirmation that the object was entirely outside the critical zone restored a fundamental confidence in the power of calculation over the allure of narrative. The clarity of the figure, 1.35 AU, became a source of fear calmed by order, a reassurance that reason still governed the ultimate terms of observation. To stand at 135 AU is to exist at the precise edge of order, free from magnetic chaos, yet still subject to a thermal exposure strong enough to drive sublimation and create a visible coma. This profound realization led the community from doubt toward revelation. As 3I Atlas moved through its closest arc, instruments continued to watch for changes in its luminosity and light spectrum, seeking evidence of ice transforming directly into vapor through the persistent sublimation process. Although the distance spared it magnetic turbulence, it offered no shield against the intense temperature differentials. Carbon compounds released vast quantities of gas, producing a bright, visible halo that expanded even at 200 million kilometers from the star. This was not chaos. It was measurable, understandable process. For the first time, in an era of contested information, the numerical unity felt quietly revolutionary, relying not on institutional persuasion, but on shared mathematics. The quiet agreement between separate observers felt like honesty returning to the discourse. The cosmic lesson for all who watched settled into proportion. Stability is maintained not by strength, but by distance. This established the rituality of the solar cycle, wherein nature respects distance as it enforces consequence. Yet, after all the geometrical precision, a completely new layer of the object's nature emerged. As it approached the sun, its brightness surged far beyond all initial prediction, growing steeply, rapidly, and uniformly across multiple instruments. The increase was logarithmic, suggesting a combination of volatile release, refractive changes, and dramatic structural evolution near the nucleus. Then came the distinct shift in color. Against the natural golden light of the inner solar system, 3I Atlas turned a vivid, persistent blue. Reflectance curves and color indices confirmed a consistent shift toward the shorter wavelengths, a phenomenon that no single mechanism could easily explain, as dust scattering typically reddens light. This unusual blue tone held steady through the perihelion, suggesting an intrinsic process of transformation, not merely a reflective effect. Amidst dramatic visual change, the underlying hyperbolic orbit stayed rigorously disciplined, confirming the object remained a natural body following predictable fields of influence. For scientists trained to expect anomalies, the steadiness of the orbit was nearly as striking as the light, establishing a stark contrast between nature's stability and the emotional reaction of those who watched. This rare paradox, a body under maximum solar stress exhibiting profound visual symmetry instead of catastrophic chaos, forced a collective recalibration of expectations. The unexpected light led to a serious philosophical reflection. The object's strange behavior created a persistent tension as its structure endured while its appearance dramatically altered. If the nucleus had remained coherent, it demonstrated an unprecedented resilience, but if its appearance altered dramatically, it marked a turn toward questions no agency was ready to frame publicly. Its light curve defied all existing precedent, leading to the inescapable question of what lay beyond a simple comet. The possibility that some interstellar travelers might exhibit properties once reserved for living or engineered systems introduced a deep challenge that extended beyond physics. The term passive traveler no longer fit the implied evidence, demanding new language and new humility in the face of what was seen. The quiet community of independent observers, who had already displayed identity binding through their shared vigilance, recognized that institutional caution, while necessary, could often feel like concealment to an audience weary of omissions. The complexity of coordinating international agencies, NASA prioritizing signal verification, ESA emphasizing cross-instrument calibration, created inevitable human friction and delays. Reports even suggested that some NASA operations faced temporary funding constraints tied to government budget cycles, slowing the translation of raw data into public release. The necessary verification process, which involves mathematical scrutiny, correcting for clock drift, and normalizing photon counts across various sensors, is inherently slow because it defends the integrity of the truth. This diligence, however, is often experienced by the public as infuriating delay. The tension between open science and controlled release was undeniable, but observers outside formal channels performed the essential act of watching the heavens while questioning authority, restoring accountability without aggression. The universe does not rush revelation. The integrity of the data depends on patience as much as it does on mechanical precision. The withholding of images until verification preserves the meaning of all those that follow, honoring the idea that truth must survive rigorous scrutiny before it ever reaches public speech. The process ultimately delivered a quiet serenity by affirming that the structure of truth remained intact. The distinction was clear. The verification sequence of detection, confirmation, and dissemination is not obstruction. It is discipline. The cosmic event itself was teaching a valuable moral dynamic, that arrogance is corrected by observation, and intuition is validated by the integrity of the process. The phenomenon of the bright blue surge, recorded in gigabytes of spectral information, stands as a testament to the process of discovery. Instruments saw it, analysts confirmed it, and institutions preserved it, ensuring no theory was allowed to overshadow the evidence. Post-perihelion monitoring confirmed the object moved away from the sun with diminishing brightness, but retained an undisturbed structure. The distinction proved that accurate scale dispels fear better than any hollow promise. Reports of fragmentation and disintegration proved unfounded. The hyperbolic path remained true. The light that had momentarily rivaled the sun faded, its story now told through verified numbers rather than sensational speculation. In retrospect, the brightness surge served as both a warning about the unknown and a reassurance about the predictable physics. This experience demands a change in perspective, a recognition that future catalogs may need to distinguish between inert, reactive, and active interstellar entities, moving beyond the old categories built only on origin and composition. The challenge extends beyond measuring motion to interpreting the object's dynamic response. The acknowledgement that reclassification might be necessary carries quiet significance as it accepts that observation itself must evolve. Science, far from being a rigid dogma, adapts when the data demands profound humility. The case of 3I Atlas becomes a powerful long-term implication and a quiet lesson in reciprocity. Observation changes both the subject and the observer, and meaning arises in their measured interaction. The object now moves outward along its hyperbolic course, leaving the solar system behind, fulfilling its inevitable path. The telescopes that once captured its vivid glow have returned to familiar targets, but the memory endures in archived numbers, serving as a benchmark for all future interstellar visitors. Its light is now receding into distance, yet its meaning persists, a brief, blinding reminder that even the most routine orbit can reveal a deeper cosmic order when it is witnessed without rigid expectation. The truth remains unchanged, unowned, and infinite. 3-eye Atlas passes into the profound darkness, its trajectory confirmed, and its unusual light remembered as an enduring proof that truth, when observed directly and with discipline, needs no embellishment to be absolutely extraordinary.